Welcome back everyone. So students, we have successfully come to know that energy is quantized in Bohr's model. So what will be the Bohr's model of atom for hydrogen atom? Today we are going to talk about that. So you can mark the heading that Bohr's model of atom, and it is for hydrogen atom. It's for hydrogen atom. So students, we have successfully come to know that if it is our nucleus with positive charge, and suppose it is our first energy level having radius r1, and it is our second energy level having radius r2, it is our r2, R2, and suppose it is our third energy level having the radius R3. Okay, the radius is R3. So we have come to know, students, that here will be the first energy level, n is equals to 1. N is equals to 1. Not going straight. Let me draw it straight. So okay. So it is our first energy line having the energy E1, and that will be equals to minus 13.6 electron volt. It is quantized, we have seen. Then we will have second energy level N2, okay, and N2 will have minus, E2 will have minus 3.4 electron volt. This energy will get decreased, and so suppose this is our E3 line. This is energy level third, E3 having minus 1.51 electron volt, and you can imagine that means here there will be a line where E will be equals to 0 as it is decreasing. So the Bohr thought the atom like it, and he explained that here this is our nucleus, okay. So we know, right? So we know the electron orbits the nucleus Bohr's model. Okay, in Bohr model, electron will orbit the nucleus. Let's draw an electron. Let's draw an electron in the first orbit. पहली बार क्या हुआ, एक प्रोटॉन एक इलेक्ट्रॉन मिला, एक प्रोटॉन एक इलेक्ट्रॉन मिला, हाइड्रोजन बना, न्यूट्रॉन है नहीं उसमें, तो हमने क्या कंसीडर किया, लेट्स ड्रॉ एन इलेक्ट्रॉन इन द फर्स्ट ऑर्बिट. तो फर्स्ट ऑर्बिट में एक इलेक्ट्रॉन बनाएंगे तो वो हाइड्रोजन के लिए होगा. हाइड्रोजन इज समथिंग लाइक इट ओनली, having one electron in the first cell. So we are just considering that. Let us draw an electron in the first orbit which is orbiting the nucleus. Is orbiting the nucleus. The positively charged nucleus, the positively charged nucleus attracts the negatively charged. So this positively charged nucleus will attract the negatively charged electron. It is positive, it is negative, it will bind it with the force of attraction. Okay, so we have successfully come to know about all these things. Let me run from here so that you can see the diagram to which I want to show you, and the theory part I am going to write at the downside. Okay, so if we are saying that, here you can write, and we are saying, and we are saying that electron is orbiting at R1. So students, if we have considered one electron in the first cell, so nucleus, it will orbit in the first cell, electron at the radius R1. Okay, so it is orbiting at the radius R1, and R1 is the first radius. R1 is the first radius, and for R1 the value of n will be 1. So when n is equals to 1, so our energy E1 will be minus 13.6 electron volt. We have seen it. That's the energy. It is the, that's the energy associated with an electron orbits the nucleus, nucleus. So we have seen that means if an electron is orbiting a nucleus, so in the first cell, so that energy associated with this electron will be this much. So in the same way, we can say if we are going to the line diagram, if we are going to the line diagram, where top line is representing E is equals to 0. Okay, top line representing energy E is equals to 0, and the bottom line will show energy E1 is equals to how much? Minus 13.6 electron volt. Okay, so we have seen this. For N1 is equals to 1, 13.6, so bottommost line, and it will get decreased. It is minus 13 electron volts. So it will get decreased, and ultimately at the top you will get energy equals to 0. Okay, similarly, when n is equals to 2, E2 is equals to how much? Minus 3.4 electron volt. The line will come here. E2 and how much? Minus 3.4 electron volt. And when n is equals to 3, our E3 will come out minus 1.51 electron volt. So it is our E3. How much? Minus 1.51 electron volt. Right up to here. Okay, so we have reached up to here. We have come to know what are the energy lines. So point to remember, students. Let's say we wanted to promote the electron. We want to promote the electron. अब हम क्या करना चाह रहे हैं? प्रमोट करना चाह रहे हैं. एक सेल से, एक एनर्जी लेवल से दूसरे एनर्जी लेवल पे इसको प्रमोट करना चाहते हैं. Let's say we want to promote R1 electron, that electron which is orbiting the nucleus, R1 electron, from lower energy level to higher energy level. From lower energy level to higher energy level. Okay. Let's say we wanted to add energy to cause that R1 electron to go from so let us say we wanted to add enough energy, हमने इतनी एनर्जी दी, we wanted to enough energy. इसके बाद मैं दूसरे कलर से लिख रहा हूँ, थोड़ा कंफ्यूज मत होइएगा, लोगों को कंफ्यूजन बहुत ज्यादा होता है. Enough energy to cause that R1 electron present at R1 radius to go from the first energy level to the second energy level. हमने इतनी एनर्जी दे दी कि वो फर्स्ट एनर्जी लेवल से सेकेंड एनर्जी लेवल तक पहुंच गया. ये इलेक्ट्रॉन अब हम क्या कर रहे हैं, इतनी एनर्जी हमने इसको दे दी, कितनी एनर्जी देंगे भी हम कैलकुलेट करेंगे कि ये जंप करके सेकेंड में जा गया. यहां तक लिखिए. उसके आगे के बच्चों जैसे ये हमने इतनी एनर्जी दे दी कि हमने कंसीडर किया था हाइड्रोजन को, एक इलेक्ट्रॉन was revolving around the nucleus. Now we have supplied that much of energy that it can go to the higher energy level. That higher energy level is fixed. Okay? So that electron, you can write, so that electron is jumping up to second energy level. Okay, so we would have to give that electron, which electron? This electron, this much of energy, and what is this energy? It is E2 minus E1. E2 is higher, so from bigger value you will subtract the E2 minus E1. This much of the energy you will have to be supplied to that electron to go to the second cell. So the difference is 10.2 electron volt. So the difference is 10.2 electron volt. You can calculate. So if you gave that electron 10.2 electron volt of energy, you would cause that electron to jump from first energy level to the second energy level. First energy level to the second energy level. How much? 10.2 electron volt. Remember the unit. Now say and suppose let's say you wanted to cause the electron to jump, let's say from first energy level to the third energy level. So what will be the required energy? Required energy to make the first cell electron to jump in the third cell should be what? E3 minus E1. And E3 is how much? Minus 1.51 electron volt minus of 13.6 electron volt, which will give you the value 12.09 electron volt. So you can imagine that you can jump that electron from first to second or first to third only when you will have this much of the energy manually. These are the required energy. If you don't have this much of the energy, the electron is not going to jump from that cell to the any cell. Okay. So if you want to make jump electron from first to second, so the required energy will be 10.2 electron volt, and if you want to make that electron to jump from first cell to the third cell, so required energy will be 12.09 electron volt. अब हम ऐसा कर रहे हैं कि अब हमने इसको इतनी एनर्जी दे दी कि ये फर्स्ट सेल से इनफाइनाइट तक चला गया. लेट्स से यू प्रोवाइड एनफ एनर्जी टू टेक इट इनफाइनाइट डिस्टेंस अवे फ्रॉम द न्यूक्लियस. न्यूक्लियस से एकदम इनफाइनाइट पे इलेक्ट्रॉन को ले गए. यू वांट टू टॉक विद दैट इलेक्ट्रॉन, तो आप इनफाइनाइट पे उसको लेके चले गए, इतनी एनर्जी दे दी. Okay, so when an electron is going, to infinite, means there is no attractive force. There won't be any attractive force at that moment when this electron is going to infinite. There isn't any kind of the bondation to that nucleus. It is free from that nucleus. It is at infinite distance. It has no attractive force when R is equals to R infinite. When the radius will become R infinite, it will reach to the infinite. So what will be the total mechanical energy? If you will talk about total energy is the sum of potential energy plus kinetic energy, and both is equals to 0. So total energy is also equals to 0. So if it is not moving, so if it is not moving, so its total energy will be equals to 0. It has total energy equal to 0. So we have taken the electron. So we have taken the electron. Which electron? The electron which is present in the first cell of hydrogen atom. Electron completely away if you from the nucleus. So we have taken that electron completely away from that nucleus. Actually, we have ionized it. We have ionized this hydrogen atom. We have gone from neutral hydrogen. We have gone from neutral hydrogen. Earlier the hydrogen was neutral, and then we have taken away that electron from the nucleus to the infinite. So from neutral hydrogen H to hydrogen ion. H plus. So we are going H to H plus when we are providing that sufficient amount of energy when this electron is going to the infinite. H to H plus, and if you carefully notice, you will find and that amount of energy and that amount of energy will be nothing but the positive 13.6 electron volt. E infinity minus E1. So is 13.6 electron, positive 13.6 electron volt. So it takes plus 13.6 electron volt to take an electron away from the attractive pull of nucleus. Always you will remember it. Can mark it as even important. And determine into ion. And determine into ion. Yes, this much of energy will be required to ionize that hydrogen atom, and that energy is actually called as your ionization energy. This number 13.6, electron volt is the energy corresponds to ionization energy for hydrogen. This is the ionization energy for hydrogen. So you will find the Bohr model actually predict the ionization energy for hydrogen, and that's one of the reasons why it is useful to study and think about these energy levels. Uh, so not only you are finding not only are the radii only not the radii only. So not only are the radii quantized, radii ही केवल quantized नहीं है, but the energy level are too. Energy level भी बच्चों quantized. Okay, thank you so much.